basic law of physics states that matter cannot be created nor destroyed. That is the basic principle behind gasification. The process begins with the use of cheap and abundant feedstocks that are placed into a gasifier under high temperature and/or pressure. Gasification then vaporizes the complex molecules of the feedstock into component parts such as hydrogen and carbon monoxide. The vaporized stream of elements is called synthesis gas and/or syngas. Synthesis gas is cleaned by removing the environmentally destructive elements such as sulfur oxides and nitrous oxides that cause acid rain. The carbon dioxide can also be easily captured to reduce greenhouse emissions. With further processing, the syngas will form into a variety of valuable commodities, such as hydrogen, diesel fuels, and/or gasoline. The syngas can also be used directly as fuel to produce heat, steam, and electricity. Plasma gasification is the cleanest, most efficient process available to convert low-quality feedstocks into valuable reusable outputs. Coal is the most abundant energy source on Earth and is relatively cheap to produce, while household and industrial wastes are produced daily. By using feedstocks that are readily available worldwide, plasma arc technology enhances self-efficiency. Standard gasifiers operate at temperatures of 1600 degrees Celsius, whereas plasma gasification uses electricity and gas flow to create plasma, the fourth state of matter. With temperatures over 5500 degrees Celsius exceeding temperatures of the surface of the Sun. This facility is completely enclosed. Now imagine industrial plants that use many times the magnitude of energy and how this affects them. As conventional energy companies struggle to replace oil and natural gas reserves, plasma gasification will become a necessary part of the energy we use every time we flip on the light switch. Natural gas and crude oil prices have been increasing for many years and are still in a constant state of flux. As a consumer, we see examples of this every day at the gas pump and when we receive our monthly electricity bill. Let us introduce the equipment and the system. The waste is brought to the facility. General waste is put into the pit from the platform, and other waste from the dumping box is also added. This waste is dropped into the hopper by crane. This deposited waste is pushed into a furnace along with a small amount of coke limestone. This waste is pyrolyzed by heat from a plasma torch. At this state, it is being melted and gasified. Molten matter dispenses from the tap hole, traveling through the coke. The molten slag is deposited into water for quick quenching, reducing it into grains of approximately 1 millimeter in size. This is called slag. The volume reduction from the original waste volume is approximately 1/100. The exhaust gas is combusted completely at the secondary combustion chamber to produce energy. Combustion temperature is generally 1000 degrees Celsius, and residence time is over 2.5 seconds. The high temperature decomposes dioxins and furans. Exhaust gas from the secondary combustion chamber is cooled. Hydrogen chloride and sulfuric oxide are taken from the exhaust. The clean gas is exhausted from the stack. The slag locks up harmful heavy metals without depositing them into the environment. Landfilling with the slag will not pollute its soil. The slag is appropriate for interlocking block for parks and residential roadways, building material, and other broad range of usage in the future. Clearly, plasma gasification provides a timeless solution, and one with a much smaller environmental footprint than landfills or incineration.